Okay, so today I'm going to talk about cover crops on Irish tillage farms, and I appreciate many of you are from grassland backgrounds, but hopefully I'll be able to get my points across. In terms of what is a cover crop, well, cover crops are something that are sown on bare land that would otherwise be bare over the winter period before a spring crop. So usually before a spring crop, the land is left fallow over the winter period. Cover crops, or as they're also known, catch crops, are something that are sown during that period. They're not usually sown as to make a cash gain or to be sold as a cash crop. They're generally sown to produce some benefit either to the soil or to the next crop. Although many growers do graze them and they get a financial benefit in that way. In terms of what would they be, and what would we sow? Well, they can be either a single species, or what's probably more common these days is a mixture of species. So they could be brassicas such as mustard or radishes. They could be cereals such as oats or maybe rye. It could be legumes such as vetches or clovers. And then there are a large number of other species that can be used, such as buckwheat and phacelia, just to mention two. In terms of why would we sow these cover crops over the winter period? Well, there's a number of potential benefits, such as the reduction of nitrate leaching, which is obviously very topical these days. They can also lead to or give an increase in soil carbon or soil organic matter. They can lead to greater biodiversity. They can result in improved soil structure. And there can be a nutrient or a yield benefit to the next crop, which is of benefit to the grower. But they do introduce an additional cost. You have the cost of sowing them, you have the cost of the seed, and you have the cost of maybe destroying them in the springtime before you sow your next crop. And the question usually is, do the benefits outweigh the costs, the extra costs that are included? But I suppose we're somewhat lucky here in Ireland at the moment in that there are a number of support schemes that support the growing of cover crops, such as acres, the water EIP, and there's a number of industry schemes there as well. I mentioned that cover crops can reduce nitrate leaching, and that's of high importance in terms of water quality these days. I suppose what's happening there is that when we harvest our crops in July or August, any mineral nitrogen that's left in the soil at that stage, or mineral nitrogen that's released from the organic matter in the soil after that date, can be lost, can be carried out of the soil by any water draining through the soil over the winter period. And we know that our winters in Ireland are quite wet, so there's quite a bit of water flowing down through the soil that will bring that nitrate down into the groundwater. If we can get that nitrogen into a plant, well, then it can't be carried downwards. And that's how the cover crop works. It takes the nitrogen into the plant tissue and stops it from being carried downwards. But I suppose that the key there is that the nitrogen needs to be in the crop before drainage begins. And the key to doing that is to get early establishment, such that the nitrogen is taken up as early as possible after the previous crop is harvested and before drainage begins. And generally, once the nitrogen is in the cover crop, it's relatively safe. Although there can be situations where some of that nitrogen can be re-released from the plant material after the plant dies back or is incorporated into the soil. If that nitrogen is released before the end of drainage, which generally occurs in maybe February or March in our conditions, the nitrogen can be at loss, a risk of loss again. But generally, that risk is probably a lot lower than the risk of having the nitrogen in the soil over the winter period, in the autumn-winter period. This is just some work just to show just how effective cover crops can be at reducing nitrate loss from an arable situation. This was some work that we did at Oak Park a couple of years ago, where we were growing, having different covers between two spring barley crops. So after the spring barley crop was harvested, we cultivated the soil. And then we either left the soil green up and sprayed it off as soon as it had greened up, and then maintained the soil without any cover, any vegetation cover over the winter period. And that's this green bar here. And what we're measuring here is the amount of nitrate that's leaving the bottom of the root zone. So down at about 90 centimeters. So we're measuring any nitrate that was passing by 90 centimeters, and we were taking it that once it got that far, it was effectively lost from the crop system. And this bar that the pointer is on is the treatment with no vegetation cover over the winter period. And what we want here is ideally low numbers, and we can see that the numbers here are higher than all the other lines. So we were getting quite an amount of nitrate being lost from the no cover treatment. If we look at the blue line, that's where we didn't spray off. We just let whatever was growing to continue to grow. So mainly cereal volunteers and weeds, and we can see that reduced the amount of nitrate leaving the root zone. The bar is, or the line is much lower than the green bar. And then the third line here is where we actually sowed a mustard cover crop into the area, and we can see that the mustard cover crop gave a very rapid decline in nitrate losses, and it's just sustained across the winter period. So cover crops and indeed natural regeneration can be quite effective at reducing nitrate leaching. In terms of cover crops and climate change, and obviously climate change is a principal focus of the Signpost program, there's probably three ways that cover crops can impact. First, you can increase your carbon inputs into the soil, and you're getting soil carbon sequestration. You can also reduce your fertilizer nitrogen requirement, and that's important in terms of the carbon footprint of the system, because we know that the carbon footprint of grain is substantially influenced by the amount of fertilizer you require. So about 70% of the carbon footprint of grain is due to fertilizer nitrogen use. And cover crops can also have an impact on nitrous oxide emissions, and nitrous oxide is a potent greenhouse gas. So we'll say a little bit about each of those topics over the next few slides. In terms of cover crops' effect on soil carbon, well, any effects on soil carbon are really dictated by the amount of carbon you're actually putting into the soil. And the more biomass, or the more cover crop biomass or bulk that you're putting into the soil, the more carbon you're putting into the soil. And how do we increase the amount of cover crop biomass? Well, one of the key ways is to sow the crop early. The earlier you sow it, the more growth you're going to get over the autumn winter period. The characteristics of what you're putting into the soil are also important. So leafy green material will tend to decompose more completely, and more of the carbon that's in the material that you put into the soil is released back as carbon dioxide into the atmosphere. So it's not actually sequestered. Whereas if you use stemmy material, it's more likely to be retained within the soil. I suppose the other point to make is soil carbon changes very slowly, so the annual effect of any cover crop additions will be pretty modest, and we'll see in the next slide just how modest that can be. But it is a positive that you're putting carbon back into the soil. I suppose the other point is soil carbon sequestration is reversible, and if you don't continue to put more carbon into the soil, your soil carbon levels will actually start to decline again. So you need to have repeated inputs of cover crops to maintain any increases that you get. And while the effects on total soil organic carbon can be relatively small when you're incorporating cover crops, the effects on the labile pools or the active pools can be much more significant. And these are the pools that are more agronomically significant. They're the pools that you're more likely to see in terms of yield benefits or soil structure benefits. So those pools can be impacted to a much greater extent than the total organic matter pool. Just in terms of how much carbon is actually being put into a soil when we're incorporating cover crops. Well, if we take roughly a 4 ton per hectare of dry matter cover crop that we're putting back into the soil, which is a pretty good cover crop, you certainly want to have that cover crop sown by late August at the latest to get those sort of numbers. We can calculate that there's roughly 1.7 tons per hectare of actual carbon in that. So biomass tends to be about 42-3% carbon, and so that would give us about 1.7 tons per hectare of carbon going into the soil, but not all that carbon is retained. And typically maybe we will take a figure of around 20% retention of the carbon in the soil. It can be much higher or lower than that, but we'll just take 20%. And if we take the 20% figure, we're getting about 0.3 of a ton per hectare of carbon being put into the soil. And when we take that in context of the weight of soil that's in a hectare, that's very, very small. And typically you're not going to be able to measure that amount of carbon by doing a soil test. you need a number of years before you'd be able to detect those sort of levels in a soil test. I mentioned that early establishment was key. This was some work that we did where we had 3 sowing dates of cover crops, late July, mid-August, and early September. And we measured the biomass at each in December of each of those sown dates. And I suppose the only point I want to make here is there was a straight line reduction in biomass production as we delayed the sown date. So early sowing is absolutely key in terms of getting high amounts of biomass. So I mentioned that cover crops, they take up all of this nitrogen, and the question is, well, can we reduce when we plough these or cultivate these cover crops back into the soil, can we reduce our fertilizer nitrogen in the succeeding crop? And I suppose in order to be able to reduce our fertilizer nitrogen, we really need the nitrogen release from the cover crop to be synchronized with the crop demand. And that probably doesn't always happen as well as we would like. And typically the fertilizer replacement value, or the amount of fertilizer you can reduce, the reduction in fertilizer inputs as a result of cover crops, is usually fairly low. Perhaps with the exception of where you have a high amount of legumes in the mix, where you can probably get a reasonable amount of nitrogen out of the cover crop and into the crop, into your cash crop. But I suppose one of the things that we need to be careful of is if we are going to try and take account of the fertilizer effect of cover crops, it needs to be predictable, because if we're not able to predict it, we're likely to over or under fertilize our crop of barley or wheat or whatever it is. So, and that's not so easy to predict how much nitrogen is coming from these cover crops. Just as an example of how small or how modest the fertilizer effect of the cover crops can be, this is some work that I saw from France. And just to explain these graphs, the further right on one of the graphs, that the point is the higher the amount of nitrogen that was in the cover crop when it was incorporated. And then if the point is above the line, we're getting a positive effect from incorporating that cover crop. In other words, we could reduce our fertilizer nitrogen. And if the point is below the line, it was actually a negative effect, and ideally we should have put a bit more nitrogen onto the crop to get the same yield. But if we just look at 2 points there in the brassicas, so this was done with 2 types of cover crop, with legumes and brassicas. If we look at the left-hand point, which is about 17 or 18 kilos of nitrogen in that cover crop, the right-hand point had close on 80 kilos of nitrogen per hectare in the cover crop when it was incorporated. And when we look at the fertilizer effect, it was slightly negative for both of them. In other words, we're getting no benefit of that nitrogen. And we've seen that in our own trials in Oak Park as well, that often the fertilizer effect is quite small. If you want to get a reasonable fertilizer effect, you probably need to have well-established legumes that have a reasonably large amount of nitrogen in them when they're being incorporated, in order to get that fertilizer effect. In terms of nitrous oxide, as I mentioned, is a potent greenhouse gas, and we certainly don't want to be increasing that by using cover crops. And I suppose one of the principal sources of nitrous oxide is a process called denitrification, and that process needs 3 things. It needs a carbon source, it needs nitrate, and it needs low oxygen. And when we think what happens when we incorporate a cover crop into the soil, we just said we're incorporating carbon. There's also nitrogen in there. So we've 2 of the 3 criteria satisfied. And then often we're likely to get wet conditions after we incorporate the cover crop. And also, if the cover crop is breaking down, that decomposition process will use up oxygen in the soil, and therefore we get low oxygen. So the three criteria is satisfied potentially on occasion when we incorporate cover crops, and therefore nitrous oxide production is a risk when we incorporate cover crops. But there's very little research in Ireland on the amount of nitrous oxide produced as a result of using cover crops. So research from abroad would suggest that, yes, on occasion, cover crops can increase nitrous oxide, particularly if there's a lot of legumes in there. But overall, it doesn't seem to be a large effect. But hopefully we'll have some new information on that in the not too distant future under Irish conditions. I suppose the other thing we often don't think of is if nitrate is lost, is leached out of the system, it gets into the groundwater or surface waters, it can be denitrified there, and the nitrous oxide can be lost outside of our field. But if the cover crops are actually preventing that nitrate from being lost in the first place, then that indirect nitrous oxide emission can't occur. So they can have a positive effect in that situation. So in summary then, cover crops, they can reduce nitrate leaching, they can contribute towards soil carbon sequestration, they can affect direct greenhouse gas emissions. It remains to be seen exactly how they affect them. I suppose the one point I would make is that the cover crop effects are all linked to the amount of biomass. The size of the cover crop effect is linked to the amount of biomass produced. So the less growth you have, the less of an effect you're going to have. As I said, the end contributions to a succeeding crop are often quite small. But I suppose to sum up, cover crops can positively impact environmental sustainability on tillage farms, but there can be a net economic cost involved in the growing of them.